foundations of modern endoscopic imaging go back nearly a half-century, and it was largely a result of the innovations of one man who persisted in developing this technology at a time when few other surgeons were interested or saw any value in the use of a laparoscope in surgical practice.
You remember that in 1962, when he was still in Australia, he had written that it seemed inconceivable to him that surgeons weren't more engaged and hadn't adopted the techniques of laparoscopy. How prophetic he was even then.
George Berci was born in Szeged, Hungary in 1921 to a family of musicians. At age 2, the family moved to Vienna, where his father had obtained a job as assistant conductor of the Vienna Philharmonic. By the age of 10, he was playing concertos and serving as the youngest concertmaster in the history of the school orchestra. After completing high school in 1939, he wanted to attend the University Medical School, but was unable to gain admission because of the restrictions on Jews. Instead, he obtained a position as an apprentice in an electrical shop for 1 year and then worked for 2 years in mechanical engineering.
And I have to admit that at later stage it was a help for me because I know how to mill, how to drill, I could measure, and I can make drawings.
During World War II, young Jewish men in Hungary were conscripted to work in labor camps across Eastern Europe.
In 1942, my age group between 22 and 24 years old were called in to labor camp.
Later, Berci's unit was sent to Poland, where he worked unloading explosives for the Germans. Eventually, with the Russian advance in the east, they were moved back to Budapest, where they were to be transported to other camps in Germany or Poland. However, only this time, it was not to labor camps.
They were going to put them all on trains now that they knew that they didn't need a labor crew anymore because the war was almost over. They were taking them back to the railroad station to put them on trains to Auschwitz and Birkenau.
They put us in a large last carriage, and somehow the brakes, they couldn't release it. And after 1 hour they're playing around, there are 85 youngsters. They left this carriage there, took the rest of it.
They detached his car and they took the rest to Auschwitz.
In June 1944, during an American air raid over Budapest, the guards for Dr. Berci's unit disappeared, and he and his fellow prisoners escaped.
The first thing is we had a yellow armband. I removed my armband, and by coincidence I found my mother.
One day, Dr. Berci was out looking for a job, waiting for the tram, when someone recognized his Viennese accent. It turned out it was a member of the Hungarian underground who needed German speakers.
That time, life didn't mean very much because we saw how many of our friends were killed. Therefore, you became very fatalistic. You really couldn't care less.
In January 1945, Budapest was liberated by the Russians. In 1945, Berci was accepted into medical school at the university in Szeged. To help pay for expenses, he worked evenings as a technician in the Department of Physiology and Biochemistry. In the 4th year, he won a prize from the Department of Surgery, which gave him free room and board. And he worked almost every night giving anesthesia for emergency cases and helping the nurses clean instruments. In 1950, he graduated from medical school and started his surgical training in Szeged. It was during surgical residency that Berci became interested in experimental work. His first study was looking at methods for preservation of arteries, work which they subsequently published in 1951. In October 1956, Dr. Berci was working in the University Hospital in Budapest as a general surgeon when the Hungarian Revolution overthrew the communist government in Hungary. The Hungarians' freedom was short-lived, however, as several days later the Soviet Politburo reversed course and sent troops into Hungary to crush the revolution. In the central square in Budapest, they suddenly opened fire on thousands of demonstrators. The hospital where Dr. Berci was stationed was nearby and received numerous casualties.
We received, within an hour, we were very near to the parliament, relatively near, approximately 250 severely injured people.
Following the escape from Hungary, Dr. Berci obtained temporary work at a university clinic in Vienna. He then interviewed for and was awarded a 2-year Rockefeller Foundation Fellowship. With that support, he decided in 1957 to leave Europe and immigrate to Australia. Why Australia?
George listened a lot to Radio Free Europe, and in the United States in the 50s, they were talking about the possibility of a communist infiltration, that they were coming to our shores at any moment, and George just decided, I'm not going any place where somebody's going to be landing on the shores where there's going to be another war, and he just thought, Australia, nobody's going there.
In 1957, you arrived in Australia with a Rockefeller Fellowship, not speaking a word of English, and having no idea where you were going to work.
That's correct.
Within 6 months, he'd learned enough English to communicate and began running an experimental surgery program. His early work focused on the problem of portal hypertension and esophageal varices in an induced canine model of cirrhosis. As a part of the study, he began performing laparoscopy in the animals to assess their livers. For this work, he won the Glisson Prize of the Royal Australasian College of Surgeons and was awarded with a lectureship position at the University of Melbourne, the first ever given in surgery in Australia to a foreigner. He also was able to obtain a medical license and operating privileges at the University Hospital. Soon his interest shifted from portal hypertension to the biliary system and the problem of common bile duct stones.
And this brought me to the idea, seeing the cystoscope, that why don't we use something to look into the tunnel to see what we're doing or what we should do.
Berci began using a cystoscope to examine the interior of the bile duct, but the image was dark and visualization was poor.
This is where my coin dropped, that we have to find a better system.
At that time, cholangiography was also very primitive and involved use of still images only. So he brought a fluoroscope into the operating room and began using it to perform cholangiograms. It was the first such unit in Australia and one of the first in the world. Berci also began performing laparoscopy clinically, initially to do biopsies for staging oncology patients. In 1959, Berci visited the Royal Technical Institute in London, where he met with the chairman there, who was one of the inventors of image amplification. Berci arranged to meet Hopkins, who was somewhat suspicious of foreigners with a strong accent, over dinner.
He took me to the lab and he showed me his prototype. And then I saw from the performance that this is a revolution in optics.
Sometime after that, Berci made contact with the head of a small company whom he had met a year earlier who was interested in surgical instrumentation and visualization. The head of that company was a man by the name of Karl Storz.
You have to develop a new polishing, glass cutting, etc. to get these rod lenses. And Storz was interested in this.
Berci persuaded Storz and his daughter Sybil to go to London to meet Hopkins. Storz was likewise impressed and was able to purchase the license to the rod lens technology. But it took time to develop the machinery to produce the glass rods.
Professor Berci and my father have had one specific characteristic in common. They were not satisfied and almost restless until ideal solution was found. That means that many discussions, many prototypes has been made and produced and tested.
Within 2 years, Storz began manufacturing Hopkins rod lens scopes for surgical use. Initially, cystoscopes where the demand was greatest, and later laparoscopes.
I think George Berci's greatest contribution is the early work he did with Karl Storz on the rod lens telescope, because that's the tool that really made laparoscopy possible.
Meanwhile, Berci became interested in recording images seen through the endoscope and in 1960 developed the first TV camera for recording endoscopic procedures. With the help of an electrical engineer, Berci was able to get a 1/2-inch camera video tube produced which weighed only a couple of ounces. He began recording images with this new system, and in 1961, at a time when many families did not even have television, published a paper entitled Medicine and Television. In 1962, Berci began a year of fellowship with Henry Harkins at the University of Washington in Seattle. It was also there that he got the first choledocoscope from Karl Storz, and, with Harkins, began using it in the operating room. He met the chairman of the Department of Surgery, Leon Morgenstern, who would become a lifelong colleague and friend.
Well, I invited Dr. Berci in 1967 to join the Department of Surgery as a visiting scholar or a visiting scientist for a year.
As a result of his work on various prototypes across multiple disciplines, Morgenstern invited Berci in 1969 to join the full-time faculty at Cedars as director of a multidisciplinary surgical endoscopy unit, a completely new concept at that time.
He quickly became involved in the surgical procedures in nearly all of the surgical departments, even when they didn't ask him. He made a lot of requests, and I wasn't sure I could afford what he asked for, but I gave him what he wanted.
Berci's work during the 1970s at Cedars impacted virtually every surgical specialty. His improvements to the cystoscope transformed the field, improving diagnostic cystoscopy and leading to a shift from open prostatectomy to transurethral resection for benign prostatic hypertrophy. With Paul Ward, he developed a 5mm indirect laryngoscope that replaced mirror laryngoscopy, and he also developed a direct operative laryngoscope with Ed Cantor. He introduced colonoscopy at Cedars and in 1973 published the first series of 100 successful colonoscopic polypectomies.
This is a drawing that George and I sent back and forth to each other back in the 70s of a bipolar snare. And based on these drawings, we would build models and try them out. And this is what George was so good at.
And George developed a right-angle scope with Storz and then introduced it. And it became the standard before flexible choledocoscopes, and George was the father of that. And people forget that he was the master of the common bile duct.
One of Berci's greatest contributions to surgery during the 1970s, however, was his work on illumination for endoscopic visualization. The globe arc light in use at that time generated tremendous heat and was prone to explosions.
We found this ceramic globe which was developed by the American Army. That we got this one and we built the first unit and it was marvelous. And today, 32 years later, every endoscopic manufacturer, to my knowledge, using the same globe.
The other problem that remained to be solved was the inability to project images in the OR onto a TV monitor in color. But in 1984, he became aware of a miniature television camera that had been developed by Sercon that Berci helped rebuild so it could be sterilized. Along with his prior work on the laparoscope, the safer and improved light source and acceptable color video system were the two final pieces needed to extend endoscopic surgery to other areas. In 1992, Berci was nominated to serve as president of SAGES. In his SAGES presidential address, he spoke about many issues in GI surgery that are as pertinent today as they were in 1993. The importance of training and education, patient safety, controlling costs of healthcare, and being careful not to utilize technology for its own sake, but only for the benefit of the patient. We should always push the envelope, he said, but sometimes we shouldn't mail the letter.
He still sleeps with a yellow pad next to his bed so that if he gets up with an idea in the middle of the night or early in the morning, he can draw it.
In 2011, Dr. Berci was honored by the American College of Surgeons as the 17th recipient of the Jacobson Award in recognition of his pioneering contributions over 50 years to the art and science of endoscopy and laparoscopy. And Berci has recently received long overdue recognition in his native Hungary, where he was awarded an honorary doctorate from Semmelweis University in Budapest, where they also named a building after him, the George Berci Surgical Training and Research Laboratory. At the age of 90, George Berci continues to innovate and develop new ways to improve surgical technology. Among his contributions since he retired from surgical practice has been the development of video endoscopic means for intubation under direct visual control.
I think it's instructive for people who wonder if you can be productive to look at George's CV and see what he's done since he was 80.
So George is in this unique category of people who have spent a lifetime even into their 90s. And there are very few people that can look back and say, I innovated my whole life. Even though I was 90 years old, I was still trying to make the world a better place.
You'd think that George at 90 would have stopped thinking. Every day he has a new idea, and he'll call me up and he said, you know, if we took a scope and mounted it above the spine, then the spinal surgeon and everyone else in the room could see into the field better, and it would be magnified. It's so logical, but no one thought of it but George. And he then doesn't stop with the idea. He implements it. He drives you crazy until you try it, and then you go, why didn't I think of that? He's a visionary.